So welcome everyone. We will start right away and see if people will still join maybe a few minutes later. But for now, welcome everyone to this second presentation of our third series already of this EDT seminar series. Before starting into the talk for today, let me do some advertisement of our community that you can see here, and also the talks that are still upcoming. If you have followed the seminar series already in the past, you know that we have a talk every other week. So in 2 weeks, there will be Makama from Meta talking about the cyber digital twins at Facebook. Then 2 weeks after that, we will also have a talk, but we're still waiting for confirmation from the speaker for that. And then we will conclude this seminar series again with a panel discussion, as we also did for the other 2 editions. But let's start with the talk today. Today, Jan Recker will be presenting for us. Jan is a professor for information systems and digital innovation at the University of Hamburg. And besides many other awards, he was also the #1 business researcher below the age of 40, nominated or named by the Wirtschaftswoche. And he's also host of the This IS Research podcast. And his many research interests, including digitalization and digital innovation and the impact of these things on organizations as a whole, but also on individuals such as developers. But today he will be talking to us about conceptual modeling and why we will still need it in the future. In his talk named From Representation to Mediation, a new agenda for conceptual modeling research in a digital world. With that being said, Jan, the stage is yours.
Thanks so much, Daniel. Hello, everyone. Nice to be seeing your Zoom panels. We all gotten used to that. Just give me 1 second while I set up the presentation. Here we go. Yeah, under 40, that's a couple of years ago. So I'm well above 40 now. I just wanted to point that out as well. Yeah, so Manuel Wimmer from Linz asked me actually to talk about a paper that came out last year. And that speaks to what is actually my home topic. Yeah, so the topic that I started doing when I was a PhD student a long time ago, and continue to do, probably not exclusively, but up here and there we still do research on this topic. And this is the topic of conceptual modeling. And I want to talk a little bit about this, how this has changed over at least the last 20 years where I was involved, and sort of what has been going on, because this is really also the focus of this particular paper. And the idea is, as Daniel said, to sort of stress how relevant it continues to be, but also how different it might be for today's world. Before I do so, I wanted to introduce my new my co-authors on this paper. And what's remarkable here that we really got together just for this paper. Yeah, so we knew each other, we knew of each other, but we hadn't really worked together. But we all are conceptual modeling researchers, different generations, I dare say, so I'm much older than any of these guys. But they do some really exciting stuff. Yeah, so they connect modeling to artificial intelligence, to citizen science, to hyperautomation, to business analytics, to many of the cool and trendy fashionable topics that we have in information systems research anyway along these days. And these guys are really building their careers around trying to identify the role and relevance of conceptual modeling with this. Yeah, and so we got together to work on this paper, which was a lot of fun, and it was entirely virtual. I think we met once in person, and this is 4 years ago or something. And then of course the rest of the collaboration was digital because of COVID, and we haven't actually even celebrated the paper yet, and it's been out for like 1.5 years. Anyway, so what do I mean when I say conceptual modeling? Well, I mean this. Yeah, that's a term that we usually mean for typically graphical representations of real-world domains and information systems that we need or use for specifying, analyzing, communicating, validating systems requirement with a bunch of different stakeholders, such as developers, analysts, designers, domain experts. So it's a core thing that features in most information systems and software engineering educations. It's also what a lot of practitioners do, explicitly or implicitly. And of course, it's also been a core topic in IS, but it's always been a niche. Yeah. So just to give you a few examples, these are all conceptual models of varying types. You see UML here, you see the state charts here, Petri nets, BPMN, class diagram, ER diagrams, all these things that I'm sort of assuming you're all at least a little bit familiar with. Most people are. That's the area of conceptual modeling. It's one that we teach, it's one that we know many people do in practice, and it's one that we do research about in a variety of fields, including computer science and information systems. But as I said, it's a weird one because it goes back to the foundational times of the discipline. We've always done research on this, but it's never been as sexy or mainstream or big as other topics. Yeah. So it has been growing ever since the early days. So here's a chart where we looked at this from 1987 to 2020. It's just a rough chart. How many publications about conceptual modeling, how many citations, it's sort of steadily growing. And it's always been there, so to speak. Yeah, and it looks like it's sort of been core and active and is still being actively pursued. However, it may also be dying. Yeah, so I'll just give you a few quotes that appeared over the last sort of 5-6 years, some of which are my own, that where people that are doing research in this area have expressed a concern that it's sort of boring, outdated, might be deemed an old technology problem. It might not be valid, it might not be applicable, it might not be relevant, it might not have any utility left. Yeah, so these are also words. At the other hand, we do have researchers that do exciting new things, and apparently we do more and more research on this topic. Yeah. So what this all means, if you're in this community and you talk with the people around you, there is, let's say, a lack of security, lack of certainty about the standing and the role. Yeah. So if you put it in my words, my question was always, well, if I have a good new PhD student that comes to my door and says, what should I be doing? Should I tell him to do conceptual modeling research, or should I tell them to stay away from that topic? Yeah, sort of, that's like, do I tell them to invest the next 4 years of their life on this? Or would I say, look, Mike, just don't do it, pick anything else? Yeah, and this is not only the question that I ask myself, this is a question that a lot of people have asked themselves over recent years. Yeah, so here's an example of that from an online forum, sort of what are some of the message boards that go around. What do we do? How do we make our field relevant again? How do we make conceptual modeling great again? And there were sort of mixed responses. Yeah. So you can ask the question, why is that? Why is that? And why is that happening now? Yeah. And sort of the thesis that we put forward in this paper is, well, the world has changed in a particular couple of ways, and maybe the research hasn't. Yeah. So a few examples here. Back in the 70s, 80s, and 90s, when we talked information systems, really, we meant software systems. We meant SAP. Yeah, we meant information systems that basically manifested themselves as software that would run on a personal computer, or an office computer, or maybe, if you're very modern, on a laptop. But of course, we now have information systems that don't really live in the back of a computer screen as software. They live in our cars. They live on our wearable devices. They live in our smartphones, they live in our thermostat, or even in my toothbrush. Yeah. So we have information systems that are different assemblages, and they take a different form. And they're not only an SAP system or Microsoft Word or some of the good old Office application systems that people looked at. Yeah. There's also other things. So you would know this, of all people. I understand you do a lot of digital twin and digital objects and Internet of Things type of things. Well, we do have that saying because the internet is no longer the internet of people. It has for a long time been the Internet of Things. So there's a couple of different statistics. This is the one that I usually do. Since about 2016 or so, we have, depending on the estimate, between 20 to 50 billion electric devices connected via the internet. That's not even all digital objects. It's about 200 billion digital objects. These are just digital objects that are actually, live and connected over the internet at any given point in time. And a lot of that goes back to around 2008, where we had the first generation of true smartphones. And then we had smart tablets, smart devices, smart doorbells, smart door shops, smart windows, smart this, smart that. Everything is connected via the internet. So we have a lot of things that you could construe as an information systems, the fewest of which are actually software on our office PC. Yeah, it's not only that we have more of them, we also, these things themselves become better and smarter all the time. Now, this is just a chart that shows AI funding investment in the US. And I'm not even here to debate the question whether artificial intelligence is truly intelligent or whether they're smart or whatever. The only point I'm trying to make here is there's a lot more research has been a lot of more money has been going into R&D around these types of objects, and they can do more things, and they are better at whatever it is that they're doing. Yeah, so the performance and the scope has widened. Whether or not that's truly intelligent or not is not really the point here, but these things can do more than they ever could in the past. So more digital objects, they can do more things, and they can do them in better ways. And we see a lot of manifestations of what that now all of a sudden means for organizations. We have, especially in what people usually call digital native companies, we have an increasing use of algorithms instead of people in product design and development or innovation. Yeah, so from video games where part of the game has been designed by algorithms, not by human designers, or even to pizza. Yeah, where the toppings for the pizza are no longer chosen by your favorite pizza maker, but maybe by an algorithm that takes data from the FDDB database and matches it with recipe.com and user feedback and generates pizza toppings that are sort of healthy and what people might actually like. Yeah, so we have a lot of influence of these sorts of things. They take a very different role if you consider that, if you compare that to 20 years ago, where we had back office systems that were sort of used to automate or informate certain business transactions, such as invoice verification, procurement planning, materials management, or sales and distribution channels, or customer relationship management. Yeah, and it is taking a lot of different forms, even for organization on a broader scale. Now, on the left-hand side, this is actually an article that's very old by now. Around 10 years ago, in Australia, I was working with a retail company, Woolworth, who were operating around 1,000 stores in Australia, and mobile shopping came up. Yeah, so they had a new first version around 2011 or 2012 of a Woolworth shopping app, which now every retailer has. Back then, it was a new thing. And that allowed people to create their shopping list and sort of shop from home. And what that would mean is that some guy in a store near to you would get your order, would pick up a shopping trolley and put the stuff in, pay for it, and then package it up and put it on a truck and deliver it to your home. Yeah, so a Woolworth employee would basically fulfill your order that you submitted online so that it would be delivered to your house. Now that's fine, and in the beginning that worked just well, but then in the big metropolitan areas like Sydney and Brisbane, they ran into the situation that more and more of these online orders were submitted via the smartphones. And so people went less and less themselves into the stores, and more orders were being, submitted that some staff member in the store would actually have to pick up and fill around. So picture yourself, there's a big supermarket in Sydney, and most of the employees are running around with a shopping trolley of themselves, pushing the regular customers aside and filling it with broccoli and tin cans and all these sorts of things to fulfill an online delivery. Now, what they then did and said, well, we can't do this. We need to have what they call the dark store, which is basically an online delivery only fulfillment store. It looks like a supermarket, has all the stuff of a supermarket in it, but it won't see any customers. So they wanted to build a supermarket just for online delivery. Yeah, so they keep that separate. Their problem was they had no idea how to build one. They knew exactly how to put the layout of the store to make it conducive for shoppers to come in, to spend a lot of time browsing the aisles and pick up Snickers on the way out and fetch the green vegetables first and all that sort of stuff that makes you do upselling and cross-selling for real customers. They had no idea how to design the layout and process of a store where everything that matters was maintaining the cold chain efficiency, sort of like turnaround time of the process, was more important than cross-selling potential. Yeah, so in these stores, you had to make sure that you arrange the items in a way that allowed all the online shoppers fulfillments to go there as quickly as possible, because time is money. Yeah, so even then we had some sort of like a digital version of a store in our physical world. Yeah, and then a year ago or so, well, now 2 years ago, I saw that in the US, Walmart is now redesigning all their stores in this particular way. So they're first building a store to fulfill the digital only orders, so whatever people shop online, and then they're designing the actual supermarkets based on whatever is left. And you can see it a little bit here, right? So what you see in these sort of stores that you now have is, number one, fresh vegetables, stuff that you would want to grab and feel by yourself and not just order it online. And the second thing in the back, you see that you have these sort of semi-prepared lunch type of meals that you can pick, like a fresh salad or a sushi platter or stuff like that, that you want to pick in your lunch break and then basically eat on the dot. Everything else, you can only shop online. Yeah, so that's in some way a turn where you have things happening in the digital world first, and then you have a leftover effect, and it has an impact on what the real world later is. Yeah, and final big change is if you go deeper into systems development and program engineering practices, well, that used to be the function of the IT department. Yeah, the IT department or organization was the one that would build new systems, they would roll out SAP for you, they would maintain the master data records, the CRM system, and these sorts of things. It started then with the big organizations to say, well, we don't want to have a new IT requisition request and send it to a central IT department. We just want a quick app. So we just hire a bunch of developers and develop our own little app, set the marketing team or the operations team and so forth. So first of all, it spread within the organization, out of the IT department to the different places where it was needed. And of course, it moved outside of that organization as well. Yeah. So we have agile development now, where we co-create stuff together with our customers. We have DevOps, where the development people and the operations people come together. Yeah. And of course, we have all sorts of new dashboard type of apps like Tableau, Celonis, these sorts of things, where we're trying to make it really easy for people to develop their own little information systems. Yeah, analytics platforms, dashboard, do your own little process mining project in the back end, all these sorts of things. And it even goes further. It doesn't even have to be adults anymore. It could even be kids. Yeah, so we have drag and drop programming and sort of simple robotics, click sort of programming type of software development things that we can even teach my 7-year-old that runs around here all the time. Yeah, so even the idea of the systems analysis and designer is different now. So that's sort of a little bit, some aspects of how the world has changed over the last couple of decades. And then you can, if you believe that, then you can ask the question, well, has our conceptual modeling research kept up with these changes? And of course, if I ask it this way, I guess that the answer is, well, it has not. What we still do is this. Yeah. So if you're in this area, one of the seminal papers is a commentary paper by Yair and Ron Weber that appeared about 20 years ago in Information System Research, which was called Information Systems and Conceptual Modeling, a Research Agenda. And the centerpiece of this article is this particular model here that says, well, if we do research and conceptual modeling, we mean we look at how we use grammars to produce scripts using a particular method. All of that occurs in a particular organizational context where things matter, such as individual difference factors, like your expertise versus my expertise, your experience versus my experience, your training versus my training. It, of course, depends on the organizational task. Do I analyze a system or do I design one? And of course, there's social agenda factors, such as how big is the project, how much time do we have, stuff like that. So this has been the way that, by and large, we have thought about conceptual modeling as an organizational systems analysis and design activity that we do during requirements engineering, requirements validation, systems analysis, systems design, where we pick a grammar, UML, ERD, BPMN, PetroNet, what have you, produce scripts. These scripts should be readable, of course, to the people that are involved, so they can then complete the tasks with the help of these scripts. Yeah. So, and we think, well, that hasn't changed over the last couple of years. Yeah, and of course, in a research paper, what you would do, you do a very systematic literature review. So we did that as well. We basically looked at all the outlets where such work gets published in IS and elsewhere. Yeah, so in IEEE journals, Transaction and Software Engineering, in Journal of Database Management, which is a typical conceptual modeling, Elsevier's Information Systems, and of course, all the typical IS journals as well. I had a look at, well, what have we actually done over this past 20 years, or more accurately 15 years, since this piece was published. And now when you look at this, well, our most prominent way of doing research in this area is that we do an experiment. We take one version of a script created by some grammar, yeah, let's say an ER diagram of a certain quality, and then we create a better version of the same script by the same grammar, like ER plus, or an unclear ER diagram and a very clear diagram, or a complex one and not so complex one with color, one without colors. And we give it a bunch of people and we ask them, how well do you understand it? Or we have them do problem solving questions. And then we see how well they understand these different scripts. And then we reason back about the grammar, how good the ER diagram type is and what we could be better. So that's our number one research topic. Our number two research topic is improving the methods, the procedures. How should we work with the particular grammar? How should we use UML in the most effective ways to create understandable model? The third most prominent research stream is, what about that agent? Which personality and cognitive traits, so variables, are relevant? How important is experience? How important is expertise? How important is problem-solving ability? How important is domain experience? Yeah. So this is the sort of research that most of the papers that we do are of this kind. Yeah. So the other thing that has happened over the time is that by and large, we've followed a set of very stable assumptions. Well, before I explain to you what that means, the first thing to realize is that's actually a good thing. Yeah. So if you hire a particular community of people doing research on a particular topic, if you have stable assumptions, it means that everyone knows what everyone else is doing. Yeah, so we understand each other. We all think when we talk about conceptual modeling, we mean the same thing. We have an agreement on what is important in this area, how we should do research, how we should evaluate it, and so forth. So it's not a bad thing necessarily. The key assumptions that we all agree on are these. So for example, that what a conceptual modeling script does is that it represents a piece of a physical reality. Yeah, that we model a business process as carried out by some organization that really exists out there. Yeah, but it's usually that the model is meant as a way of conceptualizing what a digital, in a way, an information system should represent about a physical piece of reality. Yeah, we also all agree that when we talk about users, who we mean are professional systems analysts and designers. Yeah. Sometimes we talk to them directly. Sometimes we argue that we can take information system students and there are proxies for novices or something like that. But we always mean people whose work role is to develop and read conceptual models as part of the analysis and designs. Yeah, that's basically by and large who we mean with users. And of course, they're all humans, right? Why are we doing this? What the purpose of a conceptual modeling is? Well, by and large, what we mean, or what the key variable of interest to us is how well do we understand that domain that is being depicted? Yeah, so domain understanding is our main outcome that we want from a conceptual model. We will use a conceptual model to understand what's going on in that real world domain. The context is always organizational and professional work settings. Yeah, not for fun, not at home, not in the kindergarten. And what we are modeling is what people call the deep structure. So the semantics of some real world phenomenon that we're capturing in some sort of database underlying some software system. Yeah, as opposed to the surface characteristics, so the user interface, or the physical characteristics, so the technological infrastructure on which that system is based. We basically always mean the deep structure. Now, the argument that we put forward, or that I hold, is, well, that's fine, these stable assumptions, but the world hasn't been that stable. So we still research based on the stable set of unchanged assumptions, but the world has moved on and some of these assumptions are no longer realistic. We've created basically a chasm that's widening over time. Yeah, so we work off the assumption that our modeling scripts represent physical reality, but what we have already are objects that are really already shaping our reality, not just represented. Yeah, we still believe or work of the assumptions that that it is humans that produce the scripts, and it's also humans that consume the scripts, the ones that develop and read them. Yeah, but of course we already have objects, digital objects, that can do some things on their own, including developing and reading models, plus other things. So we have digital agents, not just human agents anymore. We also work of the assumptions that what we do is we model the deep structure semantics that are relevant to information systems. But of course, we have a lot of information systems that are not just software systems that run on my Windows or my MacBook. We have them that are sitting in my, my wearable, my Fitbit, my smartphone, my pedometer, whatever I have, where a lot of these distinctions between deep surface and physical are not that simple. They're more varied, and it matters. Yeah. So if I think about a Fitbit, a wearable device, or my watch here, it doesn't have a keyboard. It also doesn't have a large screen. So I actually interact with this with tapping and talking, but not writing, typing, and clicking. Yeah. So it actually has a very different surface structure, and also has a very different physical structure. On the back end of this thing are all sorts of biosensors that pick up, human bodily signals through a weird thing that is then actually being part of the database of that system that I can interact with by tapping and clicking on. And we still work on the assumption that it's a professional organizational level activity that occurs in an organizational work setting. But of course, we now use digital information system for every part of our daily lives, not just for work. Yeah, we travel with TripAdvisor, we order cars by Uber or Lime to get a scooter. We build little information systems ourselves all the time. My kid starts programming his Lego robot. So we develop and use a lot of objects or systems in everyday life, not just at work where we switch off the computer and off it goes. So that's our main explanation for why we have that feeling of we have conceptual modeling relevant, but sort of not sexy, not relevant, not applicable anymore. Well, because of that, because we have some assumptions that characterize our reality, and we have some assumptions that characterize our research, and they're no longer the same. So what do? Yeah, we thought, well, what we need is a different understanding. We need to change our assumptions about what conceptual modeling is about and what we should be researching. Yeah, and our idea about this is the following. We still have a script. The script is still fundamentally what conceptual modeling is. So some expression of some semantic of some object that we capture in a different format, but not just to represent physical reality, maybe to represent digital reality. Maybe we don't want to represent it all. Maybe we want to translate. Maybe we want to change. Maybe we want to execute things. The script is at the core. And of course, the script is still based on some grammar with certain syntax and semantics. And we use some method, rules and principles, techniques, guidelines to create it. Yeah. Well, we also have that agent that produces and consumes the script. And we got to make certain assumptions and certain characteristics of these. So someone that uses method and grammar to create a script, or that reads the script for certain purposes. But it's no longer only about physical reality. There's also this other partially overlapping, partially blurred reality, a digital reality. Yeah. So the script is really at the intersection of these two things. The agent can be either or both for that matter. Yeah. So we really have to have the same set of concepts, but with a much more relaxed understanding of what they actually mean. And finally, of course, everything is still in a context, but the context itself is very different. So what we hope you can see here is it's basically still the same sort of framework that we had from Yair and Ron all these years ago, but it has some new bubbles in it. And more importantly, all the constructs in it have a slightly different meaning. Yeah. So one of the key things in the model is that the script does more than just represent. It actually can execute. It can take one model and execute it in a particular reality, physical or digital. It can still represent one and the other. It can translate between the two things, and it can change. Yeah, you can build a script to change, to effect change in some part of reality. I'll explain that in a bit. Yeah. So a lot of these constructs, as I said, are not necessarily new, but they have an updated, we assume, well, we make certain different assumptions about them. So a script is still a statement generated in the language of some grammar, but it's suitable for purpose of mediation, not just a description or representation. Yeah, the method is basically the same. The grammar is not only about modeling real-world domains, but it could be to model physical or digital domains of reality, and that might mean we need very different grammars. The agent wasn't actually ever really defined, but it was always assumed to be a human agent. Well, could also be a digital human. Maybe it's a human producing a script for a digital agent to consume. Maybe it's a digital agent producing a script for a human to understand. Maybe it's digital to digital without any human in between. Yeah. So you see here, we're offering a bit of an expanded view of conceptual modeling, where it allows for a much broader scope and still sort of consistent with the trajectory of research that we've had. So everything that we used to do still fits in the new definition, but the new definition also fits for a bunch of other things. Yeah. So what we've done is relaxed all these assumptions. Yeah, the representation assumption, the structure assumption, agency, and context. Yeah. So if you relax the idea that scripts only model a real world domain, but maybe also a digital domain, then all of a sudden I can start drawing conceptual models of an interaction that happens on Twitter without the people on Tinder, sorry, without the people ever meeting or something. So stuff that only happens in the digital realm without a physical thing happening at all. And of course, I can model, I can use a script to model what happens, how one of these two things might change because of an interaction that is happening there. Yeah. If you relax the structure assumption, then you can actually model a little bit more how deep structure semantics are coupled to surface or physical structure elements. Yeah. And that might just be really important to model Internet of Things, digital twins, and so forth. There it becomes really, really important that you model not only that the system is about an event and a customer and a procurement contract, but also maybe physical element of the thing, or even parts of the infrastructure, of the interface that are relevant for how we actually engage with it. The agency assumption is that we're allowing for the agent that produces or consumes script not only to be human, and the context is just a much broader thing than only being restricted to systems analysis design in a classical organizational view. Yeah. So now, if you believe that, then you can make 4 changes in how we think about conceptual modeling in the digital world. Yeah, if you follow these new assumptions a little bit. So one of the key implications we think is that we need to focus much less on what is a good grammar and which one is the best grammar and how can we make a grammar better. By the way, these are the most popular grammars that we research, UML at the top, ER diagrams, and then a bunch of process diagrams like PetriNet, BPMN, and so forth, and then a couple of other ones. And this grammar and the procedures for using the grammar and method have always been the most common object of conceptual modeling research. Well, we think we need to move away and focus much more on the script itself, on the script, which is an instantiation of one particular statement that we generate. Yeah, and we're not the first to say that. Yeah, if you look in another area where I've been doing a lot of research over the years, is what is happening in business process management, where 90s and 2000s, we focused a lot on the grammars, whether it be PetriNet or BPMN or workflow specification languages like BPEL and others. Well, it no longer really matters. What people are really interested in right now are the event logs, which are individual scripts about some sequence of one process that was really executed. Who cares what we modeled this process to look like in general if we have scripts that show what the process really looked like when we did it for every single instance? Yeah, this is a matter of a script, not a matter of the grammar anymore. We want to see which is the best way of handling this process, not what is a good grammar that allows us to describe the process in general in best terms. Yeah. So if you do like the BPM people have done and shift more to the individual scripts, all of a sudden you have more research challenges. One of the ones, just to pick one of them, is that you have to realize, well, scripts can be ungrammatical. Yeah, I can create a script that violates all sorts of syntactic and semantic rules of a modeling grammar. Should I do that? Probably not. Yeah, have I taught that? No, probably not. But is it possible? Absolutely. Yeah. So we can even have scripts that don't really have a meta model of a language behind them. And the same in that, of course, I'm going to use English in hopefully a more or less correct grammatical way so you can all understand me. I could talk gibberish. Yeah. So scripts can be ungrammatical. Grammars, by definition, of course, are grammatical. They have the rules. Yeah. And if you think about it this way, then we allow ourselves to focus on a whole bunch of different ways of representing something that's going on. We picked two of them here. The left-hand side is actually an article that's a couple of years ago, which was around the Trump election in 2016 and the purported Russian influence. And that was a fascinating article because in the article, they used a lot of representations that we felt, hey, they're doing conceptual modeling here. You know, they have something like a social network graph. They had an ER diagram of sorts, that sort of class diagrams that looked a little bit like this. Of course, they were not. This is not a UML type of diagram. This is not a sequence diagram. It just looks like it. Yeah. And on the right-hand side is an article, which is an interesting one, which is about making fair courtroom decisions if an AI is involved. And if you go through that article, again, as a conceptual modeling research, you see a lot of ways in which they conceptualize and represent the fairness problem between different entity classes, such as people that are offenders, convicted, alleged offenders of different ethnicities, of different races, with a history, without a history, etc. So it's sort of like a class diagram, if you think about it, with lots of subsets and inheritance and all these sorts of things. But of course, it's not. Yeah, it's not a UML chart, and it's not grammatical, so it's not a good model, so to speak. But of course, it is, because for the purposes of what they wanted to achieve, this was a really, really good script. Yeah. So we should put the script more at the emphasis, not so much the grammar. A second key implication we feel is that, well, we shouldn't just stop at how well do people understand these models. Our key dependent variables should no longer be only domain understanding, because scripts do more things than just represent a reality. Representation and understanding, of course, is still important, but there are other variables we could look at. Yeah. Give you one example. This is an example of a service, bet protocol, that allows you to do sports betting. Yeah, so who wins the Champions League or whatever. And it runs on a blockchain protocol. And it sort of picks information from a trustworthy source like CNN Sports or something. And then it looks up the deal of the bet itself. And then it automatically has a look at whether or not the conditions of the bet, given the trusted outcome of the sports, are executed. And then the contract stipulates that, you know, I should pay you out with Bitcoins or something. Yeah. All of that happens purely automatically. Yeah. So it is a bet protocol and a bunch of different digital sources. And there are contracts, there are processes, there are data models involved, but no humans. Yeah. So the data, the conceptual models that specify how exactly all this works, they don't have to be understandable at all. What they're meant to do is to do this translation in a faithful way. And now faithful could mean a lot of things. Like, of course, you want it to be secure. You want it to be correct. Yeah. And you want it to be complete, for example. Yeah. You want to make sure that only the correct bets will be paid out with the correct amount to the right recipients by the right source and all these sorts of things. Whether or not I can read the model is completely irrelevant here. Yeah. A different example, when you think about a device such as wearable devices, or where they are often connected to sort of health and fitness type of things, what do these systems do? Well, these systems are not just done here to tell me how many steps I've taken today. They actually try to make me live a healthier lifestyle. Yeah. So if I sit too long, my watch starts buzzing and said, "Get up, Jan." And it says, well, you should really take the stairs. It literally affects change in my behavior. That's the purpose of it. It doesn't just represent my calorie intake. It really nudges me to do several things differently and make sure I go out for a run later this evening and all these sorts of things. So again, all of that runs on a script, of course. There's a script that specifies how the different data sources, yeah, for example, my steps, my blood pressure, my pulse, my oxygen levels, but also information from other sources, such as my calorie intake, which it doesn't capture itself. It relies on me typing it in every day on some sort of database. And it matches these things to create a change, to nudge me to do something different, not for me to understand it. Yeah. So really here, the key dependent variable for a good script would not be whether I can read it or my mom can read it or whoever else can read it, but really how big is the change since I started using that system running on the script? Can I change the script to effectuate a much better change in human healthcare, in lifestyle, in active sports, in things like steps taken in a day, or number of meters elevated, or whatever it is. Yeah, so that becomes the key variable of interest, even to conceptual modeling scholars. Yeah, so if you allow for that type of thinking, then of course you can generate a whole bunch of different new dependent variables. We still have level of domain understanding, the key variable that we use in our empirical studies. How, here's a script, how well do you understand it? Which factors make it to go up and down? But you could have different types of dependent variables. For example, in my translation example, you can create a dependent variable that would be something like information loss. What do you lose in the translation between one language and another, from one script to the other, from one agent to the next? Yeah, maybe in a world where information completeness is important, how much do you lose if you represent it in a different way? Yeah, if you think about my example of change, well, then maybe really the important dependent variable is distance. Yeah, distance between whatever the old reality was and the new reality was. It could be as mundane in my Fitbit example of the number of steps that I now take more every day because of a change I made in the conceptual modeling script that specifies how this little system works. Yeah, and of course, if you think about execution, like my bed protocol example, then you could have a whole bunch of performance dimensions, such as timeliness, effectiveness, completeness, but also maybe, I don't know, a footprint of it, ethicality of it all, perceived usefulness of it all, perceived satisfaction with the execution. A whole range of performance variables become of interest and could be studied by conceptual modeling scholars if you all conceptualize, if we change a system based on way that the script is run. Yeah. And of course, the third main big implication is that we have to start taking the agent seriously. Yeah. So number one, the human agents, they don't have to be professionals. Now, what we normally do is something like this. Yeah. When we talk about the agent, the developer or the reader of a conceptual modeling, we typically think about sort of individual difference factors such as familiarity, education, conceptual modeling, experience, yeah, sort of knowledge. Duration, that's experience in years. Intensity is the frequency by how often we model, how often we read a model. These sort of 5 dimensions is usually what we take to describe the human agent, all based on the assumption that it must be some novice or some senior expert professional. Yeah, sometimes it's a student, but it's usually a proxy for a professional analyst. But it doesn't have to be, as I explained. Well, what we first of all now need is a similar thing for a digital agent. We don't even know what variables to use to characterize a digital agent that engages in modeling. How do we conceptualize then? My bed protocol example, there's no human agent involved in here. So the creator and the reader is actually an oracle. Yeah, so like a blockchain, a middle layer service called an oracle that has to read the script. Well, it doesn't matter how long it's been doing that. It doesn't matter to which university it went. Yeah, so we need something else. Yeah, so we know that they exist. We know already that we have digital agent software that can build models. We also have software to read models. How do we distinguish between these different types of digital agents? Yeah, that's just basically one way of doing this. You could have a look at and thinking about how autonomous do they act? How do they learn? How much of their capacity is scrutable by someone else, but that's not the point here. The point here is to really think about how we might do that. And finally, we need to emphasize the context more. Yeah, the context is no longer only the organization, it's really this intertwined reality where we move between physical and digital things all the time. And my go-to example here is Pokemon. Yeah, which a couple of years ago was really popular for a while, and sort of augmented reality. We don't even know whether the physical reality exists and the digital reality starts anymore. So then it becomes really, really complicated to figure out, okay, what's the script doing here? Yeah, in this particular example, if you remember a couple of years ago, if you followed the popular press, there were things such as, okay, how do I program this game so it doesn't make people trespass into areas where they're not allowed to go? How to make people make sure that they maintain health and safety sort of regulations while driving a car, crossing the street, all these sorts of things. Because in the beginning, that system, that script didn't have that, and people literally died while playing and hunting Pokemons. Yeah. So this is really a key thing where the context all of a sudden starts to matter. And then you have to think about, well, what aspect of the context, such as your location, where am I? Am I allowed to go here? Is it safe? Is all of a sudden very, very important to whether or not I have a little rat creature spawning there, yeah, or not. Yeah, and this is just the start of it. This is, by the way, this is the script of the Oracle that features in the BET protocol example that I had. Well, to be honest, I don't even know how to begin to describe the context in which these oracles operate. I have no idea. Yeah. I just see it's a bunch of source code and runs on blockchain. Well, so, you know, this context, this digital context is very difficult. Like, we got to find a way of thinking about that and researching about that too. So if we say accept some of these ideas, that the context is different, that we have different agents, that we do more than just represent, and that we just need to model more than only deep structures, then a couple of broader conclusions come up, such as we probably need new scripts, we probably need new grammars. I'm not sure that I can really specify everything that's going in here with an ER diagram or BPMN flowchart. Yeah, so maybe we need new modeling artifacts, like we have done in the 90s and early 2000s, where basically every IS department on this planet started creating their own grammar. Maybe we need another wave of that. And the other big thing is, I think we're better off actually talking to other research communities that have already started some variable other than domain understanding. There are people that already take the digital agents seriously and start conceptualizing, describing how we could think about software and, you know, artificial intelligence and how we might think about them. And we also have a lot of researchers outside of conceptual modeling that look at digital physical context in the way that they sort of impact on one another. So we don't have to do all of that by ourselves, but we should be better off actually, you know, taking this sort of interdisciplinarity a lot more seriously than we used to do in the past. And with that, I close. And I thank you for listening. And I, you know, hope that we have a few minutes of time to answer any questions you might have and just, you know, get your feedback on these ideas. Thank you very much.
Thank you very much, Jan. Let me give you one round of actual physical applause and also invite the others to join me while I will stop the recording.
Thank you.